Hi, everybody. You know why we're here. On the quiz or quest, it's kind of a quest because it's the majority of the chapter or the unit. There's only 2 things left we have to do after this before the unit test, so that's why it has that name. There are 2 problems like the first 2. So 2 simplifying. The test or the quest or whatever we're calling it is really not in this order. Hopefully you don't anticipate that, but there are 2 questions like this. Look for things like greatest common factor. Look for things like using the identities off the identity paper. Things that'll give away identities squared. Any power of 2 obviously on a word, or 2x. That's not a squared, that's a 2 angle, a double angle. Things like that will look like your identities. Here we don't have that, and we have no GCF. So we switch to sine and cosine. Now you can reduce this. The cosines do cancel. They do not cancel. The sines don't cancel because those are from 2 different fractions. But this is essentially one fraction or one term because it's being multiplied together. So now in order to subtract these 2 fractions, 1 over sine minus sine over 1, I'll rewrite it so we can see it. It's 1 over sine minus sine of x over 1. Now you need a greatest common factor. Of course, or greatest common denominator. The only denominator is sine. So we'll multiply that second fraction by the sine. Across the top, 1 minus sine squared. On the bottom, of course, you write your common denominator 1 time. 1 minus sine squared is cosine squared. And of course, sine is on the bottom. I know this is what we have as the answer. You could go a little further probably. At this point, it seems just sort of like trigonometry gymnastics. It doesn't really seem like really getting very far, but if you had to, you could do cosine over sine and then cosine over 1 and get cotangent cosine. So I'm okay with you leaving it either way. Technically, the fraction is really not a simplified version of that answer, but at the same time, there's hardly any difference. Now, for problem number 2, we're in the same position, but I don't know if you're looking. This is sine minus cosecant again. We just did that. Sine of x over 1 minus 1 over sine over cosine over sine. Now, if you remember our little trick from the tangent half angle formula, when you have a complex fraction like that, you can multiply everything by the common denominator. So that's a choice. I'm going to go ahead and get a common denominator in the numerator and then simplify my complex fraction. So this is going to be sine is the denominator, and we have to multiply this one by sine. So we get sine squared x minus 1 over cosine x over sine x. And again, sine squared x minus 1 is negative cosine squared. So I'm going to do a couple things here. This is going to be called negative cosine squared. That's this thing. Times the sine of x. And then the denominator is going to be 1 of each. You can see we have 1 sine x, 1 cosine x. So sine x is gone. When you reduce cosine squared and cosine, 1 of the cosines is gone. All of them on the bottom are gone, so this is negative cosine x. Simplifying is so vague, and the directions are just that, just super vague. It's hard to know when to stop. I realize that. The goal was really to get it to one word. That's not always possible. Sometimes you have like sine plus cosine. The idea is to get it as simplified as much as possible. And I know that that's sometimes difficult to know where to stop. So just, I don't know, do use your best judgment. If you have a question during the quiz, just say, hey, can I keep going? And I'll let you know. Because I know really, like that first problem, that's really difficult to know where to stop. There'll be one problem like number 3. where you're given some information, not on the unit circle, just regular information about just a Pythagorean theorem type triangle. We have quadrant 1 and quadrant 2. So I'm going to use the same picture. Here is alpha, which is in quadrant 1, and we know that the sine is opposite over hypotenuse. Here's beta in quadrant 2, and we know that the cosine is adjacent over hypotenuse. Now this one is a 5, 12, 13 right triangle. But over here in quadrant 1, we don't have that situation. Expect really kind of, I have that backwards. Sorry. I have that whole thing backwards. I don't want to erase. Awesome. There we go. All right, so I fixed my triangles. Sorry, not sure what happened. I couldn't see the 1 and the 2 apparently. And so that's how they should be situated. Alpha is quadrant 2 and beta is quadrant 1, and we still are missing this side in the quadrant, or in the triangle that's the 3, 10 something. So we know that this is going to be 9. What happened to my marker here? We know it's going to be 9, 3 squared plus x squared is equal to 10 squared. So when you subtract 9, you get 91. And the square root of 91 does not simplify. You should expect very large radicals and just large numbers in general in this problem on the quiz. Now we're going to do sine of alpha minus beta. Formula is sine alpha cosine beta. The minus is in the middle, and then it's cosine alpha sine beta. So we really are just going to take and rip these fractions right off the picture and then deal with the arithmetic. When you put in the fraction, the sign, it is 3/10. The word is gone. Times the cosine of b is 5/13. Minus the cosine of alpha is negative radical 91 over 10, and the sine of beta is 12/13. Multiply first, we get 15 over 130, expect big numbers, minus a negative 12 radical 91 over 130. These two negatives become positive. We have a common denominator. Please make this a single fraction. You can't really do anything with it. It's 15 plus 12 radical 91. There is one problem like this on the quiz. Now read the directions, please. It says sum or difference identity. It does not say any way you want. Problem number 7 doesn't give you any direction. You can do whatever you want. This says specifically a sum or difference identity. Please follow the directions. So you know my trick. I always think that if it ends in a 5, we should use a 45. So I'm going to go with 45 plus, of course, 150. That's how we get to 95. So this is the cosine of 45. Oops, sorry. Cosine. It goes cosine, cosine. So cosine of 150. With the cosine formula, this is a minus sign right here. That is from the formula. Then it goes sine of 45. Sine of 150. We're in the second quadrant, so remember that the cosine in the second quadrant is negative. Cosine of 45, radical 2 over 2. Cosine of 150, negative radical 3 over 2, minus radical 2 over 2, times the sine of 150, which is positive 1/2. Please multiply this. Some of you don't like to multiply the denominators. Please do that. So across the top, this is going to be radical 6 over 4. It's a negative, minus radical 2 over 4. When you multiply the radicals, you just multiply the numbers underneath. It's not a 5, it's a 6 there. Then your common denominator is a 4, and we have negative radical 6 minus radical 2. There are two questions like 5 and 6. And they're set up like this. So you draw the triangles once and you use them to answer several questions. Or if you're lucky, if you're paying attention, you don't really have to draw the triangles at all. Let's see what we have here. Cosine of 2 theta. Yeah. And if you look at the cosine of 2 theta formulas, if you have just the sine squared like on the embedded assessment, then you don't need the triangles because you can plug in the numbers. But we have cosecant, which we could use the cosecant. If the cosecant is 3, then the sine is 1/3. But because we also have to do the tangent, we're going to have to draw the triangles anyway. I'm just trying to plan. I'm trying to work smart rather than doing all this extra work. So I'm going to have to end up drawing the triangles, so I might as well just draw the triangles. Or the triangle, I should say. So quadrant 1, and cosecant is 3. So sine is 1/3. Opposite over hypotenuse. So we have 1 squared, which is 1, plus x squared equals 9. So this is going to be x squared equals 8. And as you know, you can call that radical 8, but it's also, of course, 2 radical 2. You pick how you want to do that. Both are good. You can use either one. Just make sure your radicals are simplified. So for the cosine of 2 theta, since I have it, I'm going to use cosine squared minus sine squared. Just my personal choice. Everything is positive in the first quadrant. The cosine, of course, if this is our angle right here, the cosine is radical 8/3. We've got to square that. Minus the sine, which is 1/3. Square that. Squaring the top, square the bottom, minus top squared, bottom squared. Pretty fast. You get 7/9. For the tangent of 2 theta, we're going to have 2 times the tangent, which is 1/radical 8. And then we have 1 minus 1/radical 8 squared. The bottom is 1 minus 1/8, which is going to be 7/8. And the top, straight across the top is 2, straight across the bottom is radical 8. We have some simplifying to do. 2 times 8 is 16 on the top, and the bottom 7 radical 8. Get rid of the radical 8. 16 radical 8 over 7 times 8. And then these reduce, so we get 2/7, right? Because 8 goes into both. So 2/7, and then we have the radical 8. Radical 8 has to come out now. It's 2 radical 2 when you multiply that. 4 radical 2 over 7. I feel like we've done that problem before. For number 7, there's one problem like this. It doesn't really tell you what to do, but it does say exact value. You can see clearly there's a decimal there, which means we're going to have to use a half angle formula. So the first thing is 157.5 times 2. So we are doing the sine of 315 over 2. 157, that's second quadrant, sine's positive there. So the plus minus on the outside is a plus. We have 1 minus the cosine of 315 over 2. Now, cosine, 315, fourth quadrant, cosine is positive. So this is going to be 1 minus radical 2 over 2 over 2. Got to get a common denominator. Radical 2 minus radical 2, this is over a plane, radical 2, and then the denominator, radical 2 over 1. We fix this and we get the square root of 2 minus radical 2 over a plane 2.